Hey everyone, my name is Jeff Falkinburg and I'm a professor here at UNL in the Computer Science and Engineering Department. I'm excited to be able to sponsor a project this year that will benefit UNL students taking courses like my Advanced Embedded Systems course as well as other engineering type courses. Additionally, our project will have a little more of a hardware and signals focus since we will be building an app to interface with real-world and real-world applications and real-world test equipment. What my team is going to be tasked to create is an all-in-one cross-platform, so it's going to work on Android and iOS and be able to function with the following prioritized test equipment. So we're going to build the app first as a dual channel function generator, and it will be able to output different waveforms on our stereo audio output. And then we'll input the capability to function as an O-Scope, so be able to input those two channels. And if we have time, we'll look into creating a spectrum analyzer functionality all in one app deployed to both platforms. This app will be used by students and faculty throughout UNL and other colleges and universities. I am the principal investigator and will be your primary contact, but we'll be working with Daniel in the CSE Computer Support Department, and we'll also ultimately be working with our students in my Advanced Embedded Systems course in the spring, hopefully to be able to beta test versions of the app. Plus, in the future, other engineering students and faculty also will use the app. A little bit of background. I've been teaching in the Computer Science and Engineering Department here for 3 years. In that time, I've been a senior design tribe lead. So I've been tribe lead helping out with projects that were VR or app-based projects, helping them design and build their widgets. I also teach a computer organization course where students learn how to design and build an iOS processor on an FPGA, the DE10 Lite FPGA. They also learn how to interface with buttons, switches, and the 7-segment displays and things like that. Additionally, I teach embedded systems where the students learn how to interface and build drivers on Arduino to interface with things like buttons and LEDs and motors and servos to eventually drive a robot through a maze. And later on they learn how to interface with an LCD so that they can and a joystick so they can build an Etch-a-Sketch, a digital Etch-a-Sketch, and a retro Pong game. Lastly, I teach an Advanced Embedded Systems class. That Advanced Embedded Systems class is where you all will be interfacing with the students. I have taught this Advanced Embedded Systems class here for 2 years now, and I taught a similar course in the Air Force Academy for 2 years prior to that. This course teaches engineering students how to develop the hardware and software interfaces of an O-Scope and a function generator. So in the course, they use a Nexus Video FPGA to learn how to, in the first few labs, learn how to design the oscilloscope. So first, they have to learn how to interface with the HDMI port to be able to display on a monitor the O-Scope display. Later, they learn how to import audio channels to the left and the right channel to be able to put these waveforms on that scope display. And in the third lab, they learn how to import or drop in a soft-core processor where they can manipulate and do some processing on those input channels before it's displayed on the display. If you want, you can click on the link and take a look at the course that will be taught this spring. In Lab 4, they eventually learn how to design a function generator so they can generate the left and right channels, so different waveforms. And you can see a sinusoidal and a triangle waveform. They learn how to design and output these waveforms on those audio outputs. The scope face that they build, and this is just a blown up version of that, this shows you somewhat how they build the scope face on the display, and then they put the channels on top of it. It'll be the O-Scope that you build will have a similar type of interface, except being able to pinch and zoom and things like that. So what is the problem? What are we trying to solve? There's lots of single function apps that are out there for Android especially, but there's limited free apps for the iOS, and there are no multifunction apps that are cross-platform, so working on both Android and iOS, so all the students can have the same app and the same interfaces. So our solution is to create that all-in-one cross-platform app. This interface shows how your function generator and O-Scope app on the left will interface with the advanced embedded systems scope and O-Scope and function generator that they're going to be building through the 3.5 millimeter stereo headphone jack, that audio cable input and output. Additionally, you'll interface the app with a standard O-Scope and function generator provided in the lab to test out your equipment and make sure it works well. However, some of the newer phones don't actually have a headphone jack native to the phone. So some phones may need a USB-C or Lightning charging point to headphone jack adapter, but ultimately this app will input and output through that left and right channel of the phone's stereo jack, and eventually we'll probably incorporate a microphone interface as well. This shows the pinout of those stereo audio cables, and one with a headphone incorporated into it. Let's talk a little more about the scope of work, what's going into that app. So we're building this cross-platform app to go on Android and iOS, and it's going to have multiple prioritized capabilities. First, we're going to get into the function generator, and then we'll get into the O-Scope capabilities, and we'll briefly talk about the spectrum analyzer capabilities as well. So the function generator, it's going to be dual channel function generator capability. The app will be able to output on the left and the right channel different waves. So a sine wave, square wave, triangle, sawtooth, typically found in function generators. The app will also be able to adjust the amplitude, frequency, and phase of those two channels. And it'll be something like, and you can take a look at the Google Play Store at the CoolSoft function generator. It looks like this, and that's what I've had in the slides so far. You're able to choose the different outputs, left and right or both, and choose the frequency and phase, amplitude of the different channels, the two different channels on that output waveform. It's going to work similar to a typical function generator that you can find in the lab, and this is actually one of the ones that is found in the lab that can do sinusoid, square, sawtooth, and triangle waveforms, and being able to change those values, the frequencies, amplitude, and whatnot. You can also find more on the Wikipedia page. The oscilloscope functionality, the app will be able to function like a standard two-channel oscilloscope by taking in those audio left and right channels and analyze that audio in the range of 20 hertz to 20 kHz, which is basically audio frequencies, and take basic measurements. So it'll include many standard things you find on oscilloscopes, like control features like triggering, time volts per division changes. You'll be able to zoom, pinch to zoom. You'll be able to move the cursors, pause and capture, do screen captures, things like that. And show you an example. The Lab Nation Smart Scope is available on Google Play Store, and it looks like this. And it has 2 different channels. It also has the ability to input via the microphone as well as an alternative. This is a typical display, and it's shown on this Wikipedia page for more information. Having the 2 channels input, and you can change the volts per division, so how much per division on this scope face grid, and then time per division, so when you're changing the frequency on the display and how much time you have per gradient, you can adjust those types of things. You can trigger at different levels, and these types of things will be incorporated into the app as well. You can also look at this PS Labs Android app. There's an actual some app code out there. You can take a look at how they created an Android app on PS Labs. Additionally, this is a standard 2-channel O-Scope that you'll find in the lab. The spectrum analyzer capability is a nice to have if we have time. It'll be able to show frequency components of ambient sound or music or your voice within that audio range, and there's more information on the spectrum analyzer, and we'll talk more about that when we get to it. But you can take a look at a couple different examples online for a couple different spectrum analyzers, and basically it's just analyzing different frequency components of sound, of audio. In conclusion, if you are interested in creating an all-in-one cross-platform test equipment app to aid engineering students here and around the world, or if you're interested in a software and hardware-driven project, please join us. We will be happy to have you. Take care. Have a great day.